Please.
Did you post like midterm or something like that?
Midterm will be emailed to everyone sometime next week, at the end of
Okay.
next.
Okay.
So we technically need to have it first week of March. So next week will be, oh,
Okay.
next week will be our first week of March. So next week, so I'll probably do it sometime, maybe over the weekend, something like that. So by Monday, I think we scheduled to have a midterm on Monday, I think, or Wednesday. We'll decide. But
So should we upload and submit the assignments that we have been doing during this time before the exam or after the exam?
anytime I will discuss what assignments you should do, and you will email it to me, make picture and email. I think that's
Okay.
simpler.
That's all. Thank you, Professor.
Yeah, I don't need to upload anything. I know it takes time. So just email, make picture and email. It's or scan it. Some people know how to scan, so you can do it faster. Scan it and attach to the email and send it to me. That's the best. Because email so far works perfect, but with that bright space, there are always issues. So, well, just email is pretty straightforward. And looks like we are working on chapter 10 right now. And that'd be the last thing that you should do to um, come up with the. So, whatever will be done at the end of this Wednesday will be for your homework to email to me. So it's the same problems I do in class, just not all everything, just like two, three problems per lecture should be good enough. They're pretty short, right? So it's not hard. So, anyways, that's great that you're looking forward to it. And we'll continue with section 10.1. So I'm glad I was able to log in earlier because that way it looks like now it works. Because last time I logged in once and then recorded and logged in twice. So I had to send you actually two recordings. I don't think they were perfect, but better than nothing. So because remember, I also tried my other computers and I also recorded another part of lecture on the other computer. So we were working with the angles, and if you don't feel comfortable looking at those recordings, we can do another exercise today, and I will just try to do. I'm not sure if I did this particular exercise already. Maybe I can go to exercise 10.1, so that'd be better. And just select a problem to refresh of what we did last time. So finding various angles, and there are beautiful pictures here, so I can try one exercise. So let us start with something like problem number 29. If you have any ideas about something else, please let me know. So in exercise 29, they already say the two lines are parallel. So the key idea parallel means that there are four equal angles equal to 112 degree angle. So there will be 112 here degrees, and there will be 112 and 112 also on the bottom, right? For the transversal to my angle 3 will be angle 4. So that's the key thing, which is not obvious, but good to think about. So 112 is also here. So two parallel lines, that's why. And then the one on the opposite side is also 112. So four angles measured 112. And then you can also find four other angles produced here, they be angles 1, 2, as well as angles 5 and 6. So these 4 angles I could find by, let's say, looking at the joint of angle 1 with 112 degrees angle, and notice that this angle, I put angle 1, will be found by subtracting from 180 because we have a
68. 68.
exactly. So pair of so-called supplementary angles, and you're absolutely correct. This is going to be equal to 68. Very good. So you say, how do you find 68? Well, you can use a calculator. You don't have to guess it or do it in your head. These subtractions, you can put in the calculator. That's what I would recommend you to do. So yes, you can use a calculator. So why not? So we can find some more nice solutions. So I can do one more. 33. Looks like there are more things happen here. So let me bring this up. So exercise number 33, that wants to find just 3 angles on the picture, angles 1, 2, and 3. So technically we could probably find all of them, but they don't want all of them. They just want particular few. So looks like right away I can see what the angle here is from my favorite techniques of taking the opposites, right? 59 degrees is here. And then I need to utilize the fact that we have some supplementary types of angles that are being present. So how can I figure out what angles 1 and 2 are? Well, looks like there is a straight line, right? So let me copy this as a joint in here. And then there will be angle measured 59 degrees here. 59 degrees. And the pair of angles 2 and 1 will be present. So what can I do to find 2 and 1? Well, it's probably, which you can use as supplementary angles again, right? For example, you might find a better way to do it, and that'd be great, because your way to solve things is always best way. So 180 minus 59. And the good thing about mathematics is that the answer is always going to be the same. So 59 degrees, and if I decide to subtract, I'll find again the angle that is sum of 2 and 1, both of those. So, well, that'd be for starters. So if I subtract, it'd be 100 and what? 21, is it? 121 degrees. That's same as if I take angle 2 and add it with angle 1. So I don't know what angle 2 and 1 are, but I need to find out. But I already know their sum is angle 1 and angle 2 is 121 degrees. So it looks like I didn't use the third angle, 65, and I could start with that right away here, 165, 65. It will be here, right? 65 will be here. So that way we already have a great start. And now how can I possibly relate the 65 degrees angle with anything else? Well, maybe I can, there's too many lines here. So I can just pull out these 2 lines, and then I need to somehow get to deal with angle 2. So I'm gonna use this transversal line, right? Transversal line. And now what can I say about the measurements? Well, looks like angle here and angle there must be the same. I say, why are they the same? Well, actually, there'll be four the same angles because lines are parallel, four equal angles. So they all measured 65 degrees, right? Four angles. And the other four will be the big ones, the obtuse. But the point of story that this enables us, look at that, to see the angle one right there. The angle one, which is 65 degrees. And that's interesting to think about. So try to make a little sense of it. So I already know what angle one is. It is 65 degrees, and that's just great because that way I can find angle measured. Angle two, whatever its measure is going to be. And how can I get angle two? Well, if one and two is together 121, so maybe from here, if I have one, maybe I'll write it again. 121 is equal to angle two plus, now instead of one, I put 65 degrees. So what I do is subtract 65 degrees on both sides of my equation, produce, and I can get whatever measure of angle two is. So it's 65 degrees. And say they cancel. Yeah, that's why I do it on purpose to get the measure of angle two. So they get the 2 pound. And this is going to be what? 56, is it? Something like that. 56 degrees. Of course, these all numbers are coming with this little circle with degree sign. I just don't write it, but we actually assume that we have everything in terms of degrees. So it looks like I already found 1 and 2 angles, and now I need to go for angle 3 measure. And how do I go for it? Well, now I need to use the line below, right? So again, I will utilize the fact that lines are parallel, and then angle 3 will be here, right? That's the one I need. And what I can utilize for that is probably the fact that we have the angle 3 with the same measurement as we have here. And let me say, Alex, so what do we have here? Well, looks like the angle will be the same for all four, right? So these are all angles 3. So angle 3 is here, angle 3 is here, here. So what is this? Well, the angle 3 is coming out. Use another color. It's not very visible. Use nice black color. So we utilize this one and that one. So that'd be the measure of angle 3 that we actually have. See, it's not obvious. You need to really make sure that you probably just use this as joints, and joints of what? Well, we just have found that there are two numbers here, 59 degrees, and the other was 65. So what I copied was this particular joint, and that's angle 3 measure, and it sum up to 59 and 65, and that will be our answer, right? And this is great. I hope you start to feel more comfortable when you say, Alex, not really. Well, just draw not entire picture, but portion of it, portion of it. So it will be interesting to go over this stuff over weekend maybe. And what else is here? Well, the other part of story was dealing with the measurement of triangle. Remember? The next section, they were talking the sum of all angles of triangles. So if I look at third angle here, if this is 65, they don't ask me to find it, but that could be utilized in an alternative way to calculate the measure. So that's 59 degrees. So to get this one, the third angle, I need to use the fact that total of three angles is equal to 180, right? 180, so it'd be a subtraction of 65 and 59. I guess you're done with the exercise, but you're doing more. Yeah, just trying to show you that you could utilize this approach a little bit differently. You could have, of course, said that after you found angle 3, then you could have used that angle 3 to find this one, or you could have found the angle, the little one, and then use it as supplementary. So looks like variety of ways. So what I can do is not to think too hard, but go for the scientific calculator. It's scientific, not yet. Keep typing. Scientific. No calculator. That's weird. Scientific calculator. Okay, it's coming up. So it's scientific calculator. I use Desmos. I like that one. So if I start typing scientific calculator, usually it appears, and then we can subtract. So again, any calculator is good, but I like Desmos. Later, when we will get to statistics part of the course, we'll see the advantage of that Desmos calculator usage. And looks like it is exactly 60 degrees measured. Again, they didn't ask me to find that measure of the third angle, but you could have approached it that way. So basically, what I'm doing is showing you that we could find measures of any angles in this particular picture. All right, so I guess I'm gonna move to the triangle story because it starts in the next part of the chapter 10, and that's 10.2 section. 10.2 is triangles, and that's, I guess, what we ended up with last time. So I barely looked at 10.2, so I'm going to stop sharing it and then share the whole thing again, so it will be all nice and clear. So let's try to go to, where do I need to go? I need to go to the next page. Like that. Okay. So triangles. So in triangles, we already have an idea. Remember, the sum is 180. We looked at this picture last time. So sum of any three angles of triangle is equal to 180 degrees, which is great. That's, I hope, familiar sound thing. And we'll utilize it, of course, when we solve various exercises. Like here, they say, if you have angle 120 and 17, what's the third one? Well, find it by subtracting both 120 and 17 from your 180. Or you could add them and then subtract whatever you prefer, and the answer is here, 43. So if you add 43 and 17 and 120, of course, the total will be 180. So that's great to realize. And then they keep doing the same kind of process that we already saw in the previous section. Look at this. So now, instead of parallel lines, they put a bunch of triangles here. But we will utilize the fact that we have 90 degrees angle, so the opposite is 90, and the supplementary will also be 90, so everything will intersect at the right angle, and that means that we have here 90 degrees angle as well. Why it's important? Well, because now I can find angle 2, right? If you look at the triangle with two angles given, and one of them is 90 degrees. When you say, how do you know it's 90? Well, this little square means it's 90 degrees, it's right angle, 90 degrees measured angle. And the other is 43 as they gave us. So I'm drawing this little triangle here. Then what's the measure of the third angle? I say, well, 43 and 47. Looks like it should be 47, right? Will produce another 90. Or if you wish, you can subtract from 180, 90, and 43, and you will get 47. And this is great because now we are moving to the next triangle, we can find angle 3. Can we? See, really? Well, if this is 47, then so will be the one on the opposite side, right? The angle measured, angle 3 is going to be also 47 degrees. They are the same in measures. That's probably our favorite setting. So we found that 47 degrees is another angle. And this will allow us to get to angle 4, right, from this next triangle. So make it bigger so you can better see. 47 is here. And 60 they gave us. See, they give you just enough information. So you need to use everything in order to find the third angle here.
73.
73. Thank you. That's great. So you found the third angle. How did you find it? You subtract from 180.
Yes, 180
20,
minus
47.
107,
Mm-hmm.
73.
Perfect. Perfect. So very good. So you already feel comfortable with this. This is great. That's the way to go. So you really want to not to wait for me to do all that, or sometimes it's hard to follow what I'm trying to say. Do it yourself. That's the best. So you found angle 4. That's angle number 4. That's what you just found. And that's 73 degrees, and that's almost finished because now you need one more angle, angle 5, right? So if you found that 73 degrees is for 4, so for 5 you get a supplementary subtract from 180. That's another favorite, and whatever it's coming out to like 107, that'll be your last piece. So one can say, Alex, if you ask me to do that, how do I describe all that on the solving the exam? Well, same way I'm doing right now. So if you find that angle and then that angle and put it down, so I will definitely see what you did. So you don't need to write it with words like they do in here. It's enough for me to see that you did that piece and then you do this triangle, and that's why I write down here what I call as complete solution. You don't have to put words, but if you want to, that's fine with me. So that's point of story. It's really worth to again do it yourself, just like you told me just now. Super. So if you just put numbers somehow, that'd be just great. So again, I'm not picking on my students when they grade things. If I see the right solution, I already feel so good that I give a maximum number of points right away. So I think it's fair, right? But anyways, let's try to see what else we have here to enjoy. And well, turns out there's just more stuff with triangles and everything that we have here. And similar triangle story is another interesting. Maybe I can clean the mess. Stop sharing it and share it again. So similar figures or similar triangles. Turns out the ones that have same angles. So for example, if I have triangle with sides, say 1, 2, 3, whatever they are, if I take triangle twice bigger, I think it's too big. Maybe I can make that one a little bit smaller. So it fits in my picture, so it will make more sense. So 1, 2, 3. So if I get 1, 2 is bigger. I think that I just made up an example. And then if I take another triangle with sides twice bigger, then twice bigger for third. So I doubled my sides. So if my side here is 1, then corresponding side to it will be measured as 2. If side was 2, then corresponding side should be twice bigger, 4. And if side was 3, then corresponding side is twice bigger, 6. So it's all being achieved by having the same exact angles measured in those two triangles. So if angles are the same, triangles called similar, so corresponding sides give us the same quotients. And that's what they're saying, similar. So corresponding side 7 and x. So if I divide 7 by x or x by 7, sometimes people prefer to divide big by small, x by 7, that has to give me the same exact quotient as if I start to divide again corresponding sides. So corresponding sides will be 8 big by small. So once we're able to divide corresponding sides, because again, angles are the same. I want to say, how do you know angles are the same? Well, it looks like these seem to be right triangles. In fact, they spell it out. They're similar. So it means that angles are the same. So those are the same angles, then these are the same, and the longest sides, like hypotenuse type, are the same. And then corresponding sides, so the opposites x to x, and then big to small, 8 to 5, has to be the same. So from here, I can find what x is. I could just clear denominator, right? Divide by 7, so I need to multiply by 7. Okay. And I get the answer. 7 times 8 is 56 over 5. Some people say, Alex, I don't like 56 over 5. It's 11 and 1/5. Yeah, you can write it 11 and 1/5 or put 11.2, whatever you prefer. It's the same thing to me, so you can leave it as 56 over 5. I believe that at the back of the textbook, they don't care for reducing fractions. Well, reducing, yes, but producing mixed numbers or something else, they just leave it like that. So the point of story, you found what x was, and let's see what they have here. So yeah, they used 11.2. Okay, so you can do the division by using a calculator, which is making sense, right? So corresponding sides of similar triangles are proportional. I think here is another interesting example that I think makes a good sense. Again, I'm gonna clean the mess. Share it again. And sometimes people say, Alex, we're kind of feeling that we're abandoned by ourselves. We want to discuss this together. So maybe what I can do is split class into 2 groups. Looks like we don't have many people in class, but I can produce 2 groups and let you think about next exercise together. How about that? I think that'd be kind of fun. Let's try it. So let me do another exercise first, and then we'll try to do one practice problems. If you split into groups, we'll see how it works. So looks like we have 2 right triangles, and they say the angles are the same. So they mark it with 1 marking. So that's important because that means that triangles have same angles, so they are similar, which means that corresponding measurements, say big has 14 and corresponding measurements here is 4. So 14 over 4 will be the same as if you have 6 and the corresponding measurement is x. So if we divide the big again, x by small 6. Please notice that when I produce the proportion, I need to be consistent. That's the key part, consistent. You have to take big triangle and divide by small, and then again, big by small. not vice versa, because it's not going to be equal. So we are able to actually measure the height of some kind of post for the lamp using your own height. If you're, say, 6 feet tall, and if you can measure the length of your shadow, which is 4, and then you can measure the length of the shadow of that pole, which is 14, you can measure along the ground, but then you don't have to climb the pole. You can just use the similar triangles to find its height. And that's pretty interesting usage of this. So you can produce measurements for various heights of buildings and everything just using shades, length of the shade. It's interesting to realize. So what I'm doing is I'm clearing my denominators, right? So I divide by 6. So just to look,
21.
and you say it's 21. That's great. See, you're good. You're quick. So in that, looks like I could think of 2 and 3. So I can reduce this by 2, and then I have another 2 to cancel, right? So I can cancel this one. Is gonna be 7, and then 3 and 7, perfect, 21, and then see, I need a little time to do that. That's great that you're so fast. So that's great. So anyways, we just produced the answer. So maybe you will enjoy it on your own. Enjoy what? Well, let me go to the exercise set, because now it's already in the next part. So I'm going to go to the exercise sets, triangles, and where are the exercises? I think it's here. See, I'm learning little by little how to use this textbook. So I need to go to the page where the exercise set is, and maybe I can give you analogous exercise to think about problem number 5. How about that? Please notice again the key idea is that we have here, are there similar triangles? No, not really. They're not similar. No, maybe not 5, I guess. Let me try similar. Oh, here will be similar. Where do they say similar triangles? I want the similar triangles. Where are you? See, this is for the whole story, I think, similar. Oh, exercise 11. So let me clean the mess, and maybe it's a good idea you try to think of exercise number 11. So what I'm going to do now to have you think about exercise number 11 is split class into smaller groups. So we'll see if that works. If not, next time maybe I'll just not split the class, we have you all think. But they say when you split it may be more convenient. There's not too many students. So maybe what I can do is just let me see how it's been done. I need to go here, breakout rooms, and create 2 rooms. I'm going to create 2 rooms. Okay, create. So you will be invited to join the room. And if you're invited to join, if you feel like it, join it. If you don't want, you say, Alex, I don't want to join it, period. Okay, don't join, it's okay. But right now, I think I split the class into rooms. So just join the room that you're invited to go to, and that way, so what to do in the room, discuss this exercise, try to do it, and then after, say, 10 minutes or so, I will close those rooms, so that way we can discuss it all together. How about that? So if you feel like it, please join it, and that'd be the way to go. Okay. Or if you just logged in, I try to put the assign you to room 1. So that way you're already assigned to room 1, so you can try to join it. Thank you. So, anyways, I tried, and I know this is experience that sometimes people can get an online class to communicate with each other, and it something I just want you to try. Maybe every once in a while, I can try to do that, so you can enjoy talking to each other because I think it's a great thing that Zoom program offers. But again, please don't worry if you couldn't do it. It's fine. So let me try to see so I can let's get that picture. I don't know how to do that. So, anyways, let me return back to the exercise 11. So that's the one that I hope you all were able to discuss. And now I know that not all of you. So again, if you discussed, if someone wants to do the exercise, find X, you can try to do it. Let's see if you'd be interested in that. If not, it's okay because we can have it as a little quiz. What is X? You can just put the answer in the chat. Remember, we had a quiz or not? I don't remember. But
For 11 or for 12 you want now?
11, because you probably discussed or maybe at least thought about it. So maybe if you could find what X is equal and put the number in the chat, you know, the chat here is the Zoom chat. It's I think another good practice. So I already see the answer and looks like that's absolutely correct answer. That's great, great. So if anybody else wants to put the answer in the chat, or if you're not sure, if you were not able to discuss it, don't know what the answer is, again, this is exercise number 11, then you can think about it and email me the answer. Why not? You don't have to think right now, panic. Maybe you're doing some other things. So just email me the answer whenever you have time for it. So that's the goal. So we little by little get used to this in-class communications, I think. Oh, great. So you're actually solved this exercise entirely. Awesome, awesome. I just thought they just put the answer, but so far everybody is absolutely correctly put the answer. Even someone saw the result. That's super nice. Just the answer is good enough. But so far I see the correct answers. That's great. And again, if you need time to think about the exercise 11, well, think about it a little bit more. I know there were some issues with Zoom or other things, and that's fine. No worries. Just try. Again, if you cannot put the answer right now in the Zoom chat, then email it to me And that'd be our little quiz for today. So before to wrap up for today, I guess 30 enough, lots of new things, breakout rooms and other things. So you may want to start to get used to these ideas. I will maybe see what else is in here, like in exercise number 17, for example. So what do they want me to do to find in exercise 17? What does CA stands for? Well, you want to read, of course, what this is all about, and usually the above statement will better explain it to you. And they say here that triangles are similar. So if you have two similar triangles, maybe I better draw them separately, so that way we better see what is really going on. So the big one was sides 9, right? And sides 15 is here. And a similar triangle to it is a little one. So it's also same angles. And they say the similar triangle has two equal sides. Both of them are 3. That's very interesting. So what do they want? They want to know what side CA is equal. Okay, so if these two sides are the same, then it means that in the larger triangle, it's also going to be a pair of the same size, or people sometimes call it as isosceles triangle, 2 equal sides, 9 and 9. Which means that 9 over 3, so the big side is 9, and the little side is 3, is here. And the big side is 15. And what will be the little side? Well, looks like it has to be quotient equal to 3, right? 9 divided by 3, so 15 over 5. So whatever way you like, but CA seems to be found. That's number 5. Is that what they mean when they put that bar about CA? Yeah, that's the length. Sometimes they put absolute values, but looks like that's what they want. They say find the length, and the length they call it CA. They say, so Alex, you did not use the fact that it's a 9 that you just started with. Well, maybe for the other exercise 18 or 19, you will be actually asked to utilize the fact it's 9. So I think for exercise 18, you could try to use what we just came up with. So what I can do is find measure GB here. See, it's important to know what they want. And GB is here. So if I know there's 3, say, how do you know that? Well, we just figured it out here, right? This side is 9, the other must be 9. So because those two are 3, so we have already 3 as one portion. So what would be the other portion? You see, if I just saw that two sides are both 9s, then it will be measured 9 subtract 3, and that will give us 6. See, what kind of exercise is this? Yeah, it looks like they trying real hard to create various exercises. I don't think it's very standard, but well, something we have here. So maybe it's a good time to stop for today, because it looks like some students may be thinking about the quiz. So we'll let you think about it. And again, email me the answer. I will send you this recording to the whole class shortly after we end right now. And that way you will be able to think about the quiz, hopefully today, if not tomorrow. If not over weekend, it's fine. And then you can email me your answer for the exercise right? And that's about it. So I'm gonna stop recording. I think it's enough. And lots of stress, right?